Okay, so we're going to make some consolidated notes for Unit 2. Hopefully this will help you understand all this stuff, and you can download this this file with blank notes on the Canvas account. So I'm going to start with defining everything about a term here. A term has at least one part, that is the coefficient, right? But and what we're going to talk about at least starts with a sign. A sign can be positive or negative. Okay, if it is the first term of an expression, we'll talk about the difference between expressions and just terms to begin with. If the sign is positive and it's the first term, that positive is usually just going to be blank. It's not going to be shown. It's going to be invisible. Okay, the coefficient is usually just like a regular number, like this one, we'll say like it's 2. Okay, that's our coefficient, and then our variable could be like x. Okay, so this, if we were going to write it out as like a normal uncolor-coded thing, it would be, if it was it would be 2x. Okay, so that's our positive 2x. Now we can have a coefficient of 1. Right, say we had negative x, right? The coefficient here is an invisible 1, right? If it's just like an invisible x or an invisible 1, the coefficient of this x is 1, right? And we can have this, or we can just have x, right? And then the coefficient of this is still 1, and the sign of this is positive, and it's an invisible positive. Okay, if it is the leading coefficient, if it is the leading term of an expression. Okay, so that is some things about coefficient terms. But what about the exponents? Okay, all of these have exponents. 2 has an exponent of 1. Okay, it's just invisible. X has an exponent of 1. It's just invisible. You may remember that anything raised to the first power is itself, right? So we just don't write the 1. We know it's there. We just don't write it, because if we were to write everything and it was itself to the power of 1, it would become tedious and slow. So we don't do that. We just leave the exponent blank. But the exponents aren't always 1. Sometimes the exponent is like squared for like the x, for the variable in this case, in which case this would be x squared, right? And if we squared the coefficient, for instance, right, well, we wouldn't write that as 2 squared. Normally, we would just write that as 4, right? So we're not going to do that. We're just going to write that as 2, right? So anyway, so that is the notes on exponents, right? Right. So remember, everything has an exponent. Anything raised to the first is anything, right? 1s are invisible. Okay, so, and then the notes on here, positives are invisible for your signs if in leading term. And we'll talk about leading terms here in a second when we talk about expressions and stuff like that. Like, well, I guess I can talk about it right now. The difference between an expression and a term is nothing, right? One term is an expression, but you can have multiple terms added together. Like, say we had 2x squared minus 4, right? This is an expression, right? There's 2 different terms. Now, these aren't like terms. We'll talk about that here momentarily, right? I can't combine these because this isn't an x squared. You should know that by now. Okay. Now I'll talk about terms with fractions. Okay, say I took this 2x squared, right? This 2, well, I guess not a 2x squared, but we take this x squared. Take this x squared here, right? But instead of 2, it's 1/2. You say it's our coefficient now is 1/2. 1/2. Well, if we look at this one and we write 2x squared, what's another way to write 2? Well, another way to write 2 is 2 over 1 x squared. So if I were to ask you, what does the x belong to, right? This is saying, hey, we're multiplying 2 and x squared, whatever we figure out x is, and the answer will be either positive or negative. In this case, we wrote it as positive, right? So, and I guess technically it's -1 if you want to put a negative in front of there too, but you don't have to worry about that. It's -2 times x squared, or +2 times x squared. Okay, but anyway, so this, if you want to think about it this way, right? Another way to write this is by saying this is 2 over 1 with x squared in the numerator, because it's the same thing as saying 2x squared, right? So this x squared belongs in the numerator, right? So it's saying like it's 1x squared over 2. I guess this one should be purple, right? But by convention, we don't write ones in front of terms. They're invisible, right? So we just write this as x squared. Okay, say we had like a 4/5 and it was -4/5 x squared. Well, we have a negative divided by a positive, right? Whenever we have a negative divided by a positive, that's a 5, divided by a positive, or a positive divided by a negative, right? It's going to be a negative, right? So this negative sign is really applicable to the whole thing. It's really applicable to the whole thing. Doesn't matter if the negative sign was on the 5 or the negative sign was on the 4. It's applicable to the whole thing. Okay. And if we had a negative over a negative or a positive over a positive, it equals a positive, right? So when you see this, you can just kind of be like, okay, that's a positive. My final answer from that circumstance is going to be positive. But back to this, I can take this x, right, and I can just kind of extend my divisor bar here and put it on top like this, right? And that'll help you out a lot when you're doing some things here further in the future. Okay, now like terms. When I say a like term, what is a like term? Well, we wrote up this earlier. We said 2x squared and then -4. Well, that's the simplest I can get it because I can't combine these. I can't combine these because they're not like terms. What do I mean by that? Well, if in order to combine these, they have to be alike in the variable, right? This one doesn't have a variable, right? So I can't combine them, right? This one is like a different species of number. Right? This is an x squared, right? If this was an x, right? Still not a like term. Okay, this is an x to the first. It's an invisible 1, right? This is an x squared. It's an invisible. It's a 2, right? So it does not allow me to combine the coefficients, right? In this case, it would be subtracting them, right? But if I change this to an x squared, for instance, if this was an x squared, these are now like terms, right? So I can combine these like terms because these are the same, x squared and x squared, right? So now that allows me to combine them. A 2 combined with a -4 equals a -2x squared, right? So that's what I mean by combining like terms. If I had like a 3z xz, and then I was trying to combine it with a 4 x squared z, right? These are not like terms, okay? They have to be exactly the same. Although they're two variables multiplied together. So it's one term with coefficients in front of them. All right, so they're not alike. If I put a squared here, still not alike. All right, it has to be exactly alike in both the variables and the exponents of those variables in order for them to be alike. So now I can combine these terms. It would make it a 7x squared z. Okay, that is how you combine alike terms. Okay, so that is that. I just did that right here, combining like terms again. So if I have a like term like 3/5 x squared y minus, we'll say, 9/3 x squared z, and then plus x, or we'll say, yeah, we'll just say x squared y plus, we'll say 8/3 x squared y. First thing I need to do is identify what is like and what is not alike. Okay, so well, I have my x squared, I'll have x squared in them, okay, but this one has a y, that's a z, and that's a y. So these are my like terms. This is a not a like term, so I'm not going to touch this one. So the only things I can combine here are this 3, I'm going to rewrite this, okay, 3x squared y over 5 plus 8x squared y over 3. Now the problem is here is I can't combine these directly because they don't have a common denominator. All right, so in order to get them to have a common denominator, I need to multiply these so that they both have a common denominator. I just need to unsimplify, right? So when you're unsimplifying, all you're doing is changing the coefficients. Okay, the variables stay the same. I'm just changing the coefficients so that I can combine the variables. Okay, so how do I do that? Well, the common denominator between these two would be about 15, right? So like I'm gonna have to multiply this one by 3 over 3. That's multiplying it by 1 in the form of 3 over 3. I'm going to multiply this one by 5 over 5. That's also just 1 in the form of 5 over 5. Okay, so this is going to go into multiplication here, but you'll see this here in a second. So all I'm doing here is multiplying the bigs, unquote, right? So when you're multiplying the numerators and the denominators, just like you would, ignore the variables. Okay, these are just coefficients being multiplied by coefficients. So the resulting is 9/15 plus 8 times 5 is 40. 3 times 5 is 15ths. Okay, and these 3's don't affect the x or y's at all. And 5 doesn't affect the x or y's at all. Right, so I'm just going to carry forth the x squared y. X squared y. Okay, now I can combine this into 1. Right, this is going to be equal to 9x squared y plus 40x squared y over 15. I can add these together because they're common, equals 49x squared y over 15. Okay, that's not the final answer, because don't forget about this guy at the very top, right? We got to take minus 9 over 3x squared z. Right? And if you wanted to combine that with the 15, you could, right? But it doesn't really matter, because you cannot combine these two terms, right? So if you wanted to, you would multiply it by 5, so you get 49x squared y over 15 minus 45 times, 9 times 5 is 45, so it'd be 45, but it'd be x squared z, right? So that would be like the cleanest way to show it, but this is not wrong, right? This is just cleaner, I guess, right? Because it has a consistent thing. Okay, so a polynomial versus a monomial expression. Okay, so you have expressions. Okay, a monomial is just one expression, just one term. It's just one term. That's your negative 2x squared. Okay, that's just one term. A polynomial is many or more than one. Okay, get a lot of focus here. Okay, it's more than one. Okay, so this can break down into like a couple of them. You know, you have your binomials, which is two terms. You have trinomials. Well, I guess they're quadratic expressions. Well, I guess they could be quadratic expressions, but they're not necessarily quadratic expressions. So they're trinomial, and so on and so forth, right? But there's anything that's more than one. These are some ones that you'll commonly see. Like, so that's the difference between a term and an expression. We've kind of already identified that. A term can be at least one, right? At least one term is an expression. But an expression can be many terms. Terms are separated by plus or minus signs, not in parentheses. Okay, so like what I mean by that is, here's an example: plus or minus signs, not in parentheses. So here's an example. Like 4x plus 5y, that's two terms. Not to be confused with 4x minus 5y. Let's do that, that'd be better. 4x minus 5y. Not to be confused with 4x times the quantity of negative 5y. That's one term. This is two terms. This is one term. Because this parentheses indicates multiplication, all because of, please excuse my dear Aunt Sally PEMDAS. Parentheses, right, is the first thing that we do, is we're gonna multiply, exponent multiply, and then divide, add, and subtract, right? So this is gonna be multiplied all together before we add or subtract, okay? It's gonna end up so if we simplify this, it would end up being negative 20 x, y. It ends up being one term, right? So anyway, that's that. Okay, on to page 3. Multiplying terms, we've kind of already showed you that. Okay, multiplying terms, but we're going to do some with exponents now. Okay, if we say we have just a couple terms, we have 3x squared. We have that's one term. This is all just one term, right? 6x y to the third negative 4z x to the negative third and y. Sure, let's do that one. Okay, so we have to identify the types of stuff we have first, okay? So here's step one, ID the components. Right, we have our coefficients. Okay. Then we have our different variables. X's, Y's, and a lone Z. How about a red? And a lone Z. Okay. Step two is we're going to multiply the coefficients. S-I-E-N-T-S. The big. Multiply the big. Okay? So 3 times 6 is 18. So 3 times 6. So here's a better way to do it. All right. So step one, the sign. Okay, a positive times a positive is a positive times a negative is a negative. Okay, then the numbers. Okay, then the numbers. So we know it's going to be negative, positive, negative. It's going to be a negative. Then we do a 3 times a 6 times a 4. It's going to be 72. 72. Okay, so that is our variable. That should have been green. Make that green. Negative 72. Okay. Then we are going to multiply the variables. So when you multiply the variables, you have to add the exponents, right? Add the big. Sorry, add the small. Multiply the big, add the small. Add the small. All right, so these are gonna be in the X's will be in yellow. Okay, so I got X. I'm doing X's now. 2. This is an invisible 1. 2 plus 1 is 3. Minus 3 is 0. Okay. Then we have Y. I made that blue. Y is 3. An invisible 1 is 4. Y to the 4th. Okay, and then my lone Z. All right. And then step 4 is simplify, if possible. All right. So is there anything here I can simplify? Well, yeah, that X to the 0. Anything to the 0 is 1. Right? So this ends up being, that's all said and done, negative 72 y to the 4th z. That's my final answer. Okay. Now dividing terms. It's very similar. Okay, say I have something that's like, it's purple again. Let's say 4x to we'll say negative 4x to the 5th, y to the 3rd, z to the 7th, divided by 6 to the x to the 3rd, y to the 6th, z to the 4th. Okay, we'll do that. So, again, step 1, ID the components. Component ENTS. All right, we have our coefficient. Okay, 4 and 6. All right, then we have our on step 2. Oh, then we have our there we go, our x's, our y's, and our z's. They're not always going to be lined up for us nice and easy like that. Our z's, that red, our z's. I guess I used the same color. Sorry about that. Anyway, so step 2 is simplify the coefficient.
Good morning.
All right, after we simplify the coefficient, so, well, first let's look at this thing. This negative sign, we can just take this negative sign out and just put out in front. We know it's going to be negative. Now we can stop worrying about that negative sign. Okay, that 4 over 6. Well, can we simplify 4 6? 4 6. Hey, that's 2/3. Let's simplify that. That is now going to be 2/3. All right. Now we can do number 3. Step 3 is going to be divide. D-I-V-I-D-E, divide the variables. Variables, right? And that's going to be subtract the bottom from the top exponent, or cancel out. Whatever way you want to look at it, okay? So I like to cancel out, but you can go, all right, so this is, I'll show both ways, all right? So we're going to look at our x's. We're doing x now, okay? Where am I going to put x? On the bottom or the top? Well, it depends, right? So I have, this is my top, this is my bottom. I'm going to go 5 minus 3, right? That's going to be positive, right? So my x is going to be on the top. By how much? Well, 2 is left over. 5 minus 3 is 2. Okay, another way to look at that is like 5 is going to go against 3. 5 wins by 2, so x squared is on top. Okay, then we have y. Y is going to be 3y minus 6. So it's going to be negative 3 on the top, right? So, or you can be like, okay, so this could be y is negative 3, and then in order to change that to a positive, it has to go to the bottom. Comes y to the 3rd, right? So that's one way to look at it. Or you can be like, all right, 3 versus 6. 6 loses. This one has 3 left over. Okay. And then you have your z value. I'm going to use orange for this one. Then you have your z value. And that's yellow, I guess. Then you have, okay, this is going to be 7 minus 4, which will be 3. So this will be positive, so it'll be z to the 3rd. Or you can just be like, okay, 7 versus 4. 7, the 4 loses, but there's 3 left over, so z to the 3rd. So this is your answer for that one right there. Okay. raising to a power. Oh wait, we gotta do multiplying other terms, multiplying terms. So say we have a polynomial. Okay, so if we have a polynomial, say we have two things like x 2x minus 3 times we'll say x plus 4. Okay, first thing, take this and rewrite it with a space. 2x minus 3. Okay, then take this and rewrite it x plus 4, like that. Right, now make yourself a little table like that. Okay, now we're going to multiply to fill these 4 blocks in. All right, 2x, so positive times a positive is a positive. 2 times the invisible 1 is 2. X times x is x squared. Okay, now we're going to move on to this one. Positive times a positive is a positive. 2 times 4 is 8. 8. Okay, x times no variable, the x just carries forward. Okay, now we're going to go negative times a positive is a negative. 3 times 1 is 3. X times no variable is x. Okay, then we have a negative times a positive is a negative. 3 times 4 is 12. No variable times no variable is no variable. Okay, do we have any like terms? X squared, no variable, x and x. Those two x's will combine to make positive, combined with a negative. Okay, that's positive 8. Combined with a negative 3 will make a 5x. Right, so this answer will be 2x squared minus 5x minus 12. So that's a polynomial. Okay? So that's that one. If you have this, say you had this thing squared, it was just this one squared, not this, you do the same thing, except you would just put this here. It'd be x plus 4, x plus 4. And if I have time, I'll show you a shortcut at the end of this. Okay? All right, raising terms to a power. Say we have 4 x to the third, we'll say negative 4 x to the third plus or times y squared z to the negative 5th. And we're going to raise that to the third. Okay, so when you do this, that 3, we're going to do PEMDAS, remember, right? Everything inside do first, right? There's nothing inside to distribute to. Okay, so what we'll do, well, nothing inside to simplify. So next we're going to do is exponents. Right, so we're going to take this 3 and we're going to apply it to every term inside. So 1 ID the term, the components of the term. Components of the term. Okay, right, the first one is negative 4. It's inside the parentheses. The second one is x cubed. The third one is y squared. The fourth one is z to the negative 5th. Okay, then we're going to take this cube and apply it to each. Like that. Okay, so if I take negative 4 and I cube it, right? Remember, if I have a negative raised to an odd will be a negative. Okay, that's the only time you're going to have a negative from raising it to an exponent, is when it's raised to an odd. So my answer to this is going to be negative, or negative 4 times negative 4 times negative 4 will be a negative. So 4 to the third is going to be 64. Negative 64. Okay. Then we're going to do x cubed. So when we're raising, so 2, distribute the exponent to the coefficient. That's what we did here, number 64. Number 3, distribute the exponent to the variables. Okay, so when we do that, we have to multiply the exponents. All right, so it's going to be 3 times 3 is 9. X, this should be blue, x to the 9th. This will be y. 2 times 3 is to the 6th. This will be z. Negative 5 times 3 is z to the negative 15th. Okay? Now, if I want to leave that, that's fine. But I can also do negative 64 times x to the 9th, y to the 6th. Put it over fraction, put that z to the 15th to get rid of that negative sign in the exponent. Okay? So, combing it all together. Why did I put that? It's supposed to be bringing it all together. All together. Okay. So I'm gonna pause this for a second while I find a. Actually, I'm gonna make this one into a different video. So I'll leave you guys hanging on this one.